Hi guys, I am Kavitha. Today we are going to see the topic of graphical solution of LPP models. A linear program problem can be solved using various methods, and one such method is the graphical solution method. In this method, the solution is obtained by graphically representing the constraints and objective function of the LPP. Linear programming problems involving two decision variables can easily be solved by graphical method. Next, we are going to see the graphical solution of LPP models, the steps. What are the steps involving? The major steps in the solution of linear programming by graphical method are identify the problem, the decision variables, the objective and the restriction. Set up the mathematical formulation of the problem. Plot a graph representing all the constraints of the problem and identify the feasible region. The feasible region is the intersection of all the regions represented by the constraints of the problem and is restricted to the first quadrant only. The feasible region may be bounded or unbounded. Compute the coordinates of all the corner points of the feasible region. Find out the value of the objective function at each corner point. Select the corner point that optimizes the value of the objective function. It gives the optimum feasible solution. These are the major steps. We convert into 4 steps in here. Next, the important note is, if there is no permissible region in a problem, then we say that the problem has no solution using graphical method. The feasible region we get only in the first quadrant. If doesn't have the solution in the feasible region in the first quadrant, then the solution is no solution. If the maximum value of z appears only at infinity, then the problem has unbounded solution. If the maximum value of z appears at 2 points, there exists infinite number of solutions to the LPP. These are the some exceptional case of graphical solution method. Next, we see some problems for graphical solution of LPP. Solve graphically the given linear programming problem. Maximize z is equal to 4x1 plus 50x2 subject to x1 plus 2x2 less than or equal to 40. 4x1 plus 3x2 less than or equal to 120 and x1 comma x2 greater than or equal to 0. First step is we considering the constraint inequality as equality. We have the first constraint is x1 plus 2x2 less than or equal to 40. Equation of this is x1 plus 2x2 is equal to 40. We put x1 is equal to 0, then we get the x2 is 20, and we put x2 is equal to 0, then we get x1 is equal to 40. We get 2 points 0, 20 and 40, 0. We use these 2 points to draw the first constraint. Let the second constraint is 4x1 plus 3x2 less than or equal to 120. Equation of this is 4x1 plus 3x2 equal to 120. We put x1 is equal to 0, then we get x2 is equal to 40. Then x2 is equal to 0. We put x2 is equal to 0. We get x1 is equal to 30. Then we get the points 0, 40 and 30, 0. We use these 2 points to draw the constraint 2. The third constraint is x1, x2 greater than or equal to 0. This is non-negativity. x1 is equal to 0 and x2 is equal to 0. We use these two axes for this graph. Now we draw the graph for this. The two lines intersecting, the two lines are less than, therefore we get the feasible region. In the pink color is the feasible region. The corner of the feasible points are 0, 0, 10, 20, 0, 20, 24, 8 and 30, 0. Next, we take the corner points and substitute the values in z. Z is equal to 40x1 plus 50x2. First we get the corner point is a equal to 0, 0. We substitute x1 is equal to 0 and x2 is equal to 0. Then we get z is equal to 0. And the point is b. We substitute x1 is equal to 30 and x2 is equal to 0. We get z equal to 1200 and x1 is equal to 24 and x2 is equal to 8. We substitute these values, we get z equal to 1360 and x1 is equal to 0, x2 is equal to 20, we get 1000. These 4 values we get the maximum value is 1360. This is the optimal solution. Therefore, the optimal solution is maximize z is equal to 1360, x1 is equal to 24 and x2 is equal to 8. Okay, thank you.